Hello and welcome to our third video on our series on monetary economies. In this video, we're going to be talking about nominal and real interest rates, and we're going to get to them by discussing the differences between nominal bonds and real bonds. Critical in the analysis of how different types of assets like nominal and real bonds relate, it's the concept of arbitrage. And so we're going to go through that as well. So let's start by thinking about a specific type of asset, the nominal bond. When we say a bond, we really mean a contract. It's a piece of paper that stipulates some payments. What makes the bond nominal is that these payments are going to be carried out in dollars, in money. Because they're in dollars, that's what makes them nominal. And there are basically two types of these nominal bonds. The first type we're going to call a normal bond. In a normal bond, you pay B dollars today for a piece of paper that pays 1 plus R times B dollars in the future. So here, as with the general case, as I said in the first bullet, a nominal bond is a contract, a piece of paper that stipulates payments. So the payments here are you pay B dollars today, you get 1 plus R times B dollars in the future. We're going to call B the face value of the bond. In the future, though, it's going to pay interest. R is going to be the nominal interest rate. Again, nominal because it pays in dollars. And so nominal bonds can be used to transform $1 today into 1 plus R dollars tomorrow. There is another type of bond that's often used and that we're going to be seeing in the sixth module. That's the zero coupon bond. A zero coupon bond, it's slightly different. The payments are slightly different. So here you're going to pay Q times B dollars today for a bond that pays B dollars in the future. B is still the face value of the bond, but a zero coupon bond pays its face value at maturity. In financial lingo, sometimes these interest payments are called coupons. And so a zero coupon bond is a bond that pays no interest. So there is no interest, but in exchange, there is a discount when buying the bond. So usually you're going to find that Q is less than 1. This means that you're basically paying less than $1, say 90 cents, for every dollar that you're going to get in the future. So, well, you can use normal bonds to transform $1 today into 1 plus R dollars in the future. You can use a zero coupon bond to transform Q dollars today, that's the price of the bond, Q, into $1 tomorrow. Now, I'm introducing these two types of bonds because the relationship between them, how their prices are related, it's a good example of how to apply arbitrage to understand the relationship between different interest rates. And so let's talk about it in this example. It must be that Q is equal to 1 over 1 plus R. If they weren't equal, there will be an arbitrage opportunity, and that cannot happen in the market. And so how will that work? Imagine for a moment that Q is actually less than 1 over 1 plus R. I'm going to show you that you should borrow money with nominal bonds by selling bonds for B dollars. And a quick note there, B can be negative. If B is negative, it means that instead of buying bonds, you are selling bonds. So if you're selling bonds for B dollars, that means you now have B dollars that you didn't have before, but now you have to pay 1 plus R times B in the future. So you have money now, you have to repay in the future with interest. One thing you can use that money for is to buy zero coupon bonds. Because the price of a zero coupon bond is Q, you combine 1 over Q times B of those bonds. And because these bonds have a zero, they don't pay any interest, you have to pay tomorrow that same amount. And so you will get paid tomorrow 1 over Q times B. To recap, what you're doing is you're borrowing money with a normal bond. Tomorrow you have to pay back that money with interest. You're going to use all that money to buy as many zero coupon bonds as you can. You can buy 1 over Q times B zero coupon bonds. Because they have to pay their face value, you have to pay tomorrow, because they pay their face value, you will get paid tomorrow 1 over Q times B. Now you make a profit if how much you have to pay, this is how much you have to pay for the debt you have, it's less than how much you get paid by the zero coupon bonds. But you can see that B here is irrelevant, it cancels out. And so as long as Q is less than 1 over 1 plus R, you make a profit. Actually, you make a profit for every dollar that you borrowed. And so you should actually borrow infinitely many dollars so that you can then buy a lot of zero coupon bonds. Those zero coupon bonds are going to pay tomorrow more than what you had to pay in interest for the borrowing that you made. And that's how you have an arbitrage opportunity. So it must be that in equilibrium, Q is equal to 1 over 1 plus R. Now we're going to go back to this example of arbitrage in a moment, but first we need to introduce the other type of bond that we're going to consider. These are real bonds. The same as nominal bonds, a real bond is a contract, a piece of paper that stipulates some payments. But what makes the bond real is that now payments are not carried out in dollars, but in actual units of goods. And so in a real bond, what you do is you pay X units of goods today, and you get in the future 1 plus little r units of goods. So payments are both today and tomorrow in terms of units of goods. Now, while in the real world most bonds are nominal, there are cases of contracts in which the payments have to be done not in dollars but in some quantity of something, and those will be real bonds. But it's still very important to understand them. The reason is that in the model, as in real life, agents care about their consumption. Agents care about real goods. And so real bonds are what's going to determine in the model the real interest rate. And the real interest rate plays an important role in determining how much agents want to invest and how much agents want to save between one period and another. That's one of the main lessons from our second module when we were covering the chapter 11 two-period model. The real interest rate was the key to that model. So here it's again as the payment of a real bond. Now, there is, of course, a relationship between the real interest rate and the nominal interest rate. And that relationship goes through thinking about how to price real bonds and nominal bonds together. So a question that can help us start thinking about that is how many real bonds can you buy with one nominal bond? Well, if you think about it, we're asking about the relative price of bonds. We know that one nominal bond is worth $1 today. One real bond it's worth 1 unit of consumption. That's kind of by definition. But we can relate them using the price because we can price consumption units in terms of our numerator, which is dollars. So P is going to be that price. It's the price in dollars of 1 unit of consumption. So one nominal bond is worth 1 over P real bonds because one nominal bond is worth $1. And with $1, you can buy 1 over P real bonds. On the other hand, if you have one real bond, that's 1 unit of consumption goods that you can sell for P dollars and you can buy P nominal bonds. So this is basically how you can go from one to another. Now, because this is only going from one type of bond to the other in the same period, this is not the whole story because bonds are going to pay in the future. So we also need to take into account how nominal and real bonds behave over time, and so we also need to know how prices behave over time. Basically, the fact that dollars in the future are not worth the same as present dollars. And so we have to introduce the inflation rate. And this is going to be neat because in the models that we're going to cover in this module and the next, the inflation rate is going to play an important role. And so we're going to define 1 plus I, the inflation rate, as the ratio of future prices to present prices. This inflation rate is going to let us compare payments across periods. The way we're going to compare them is through the Fisher equation. The Fisher equation is going to relate the real interest rate 1 plus R as the ratio of the nominal interest rate to the inflation rate. And we can actually derive it through an arbitrage condition. So let's see how that will work. Let's say that you start with $1 today. You can buy one nominal bond or 1 over P real bonds. You know that the nominal bond pays you 1 plus R dollars in the future. The real bond is going to pay you 1 plus R real goods. So you have to pass that to dollars. It's going to pay you 1 plus R real goods times the amount of bonds you have, 1 over P. And so that's the total number of units of consumption in the future that the real bond is going to pay. To compare the payments, you need to put them both in dollars. So you can sell the 1 plus R over 1 over P consumption goods for their price in the future. So you can sell them at a price P prime. But then you get 1 plus R, this is this first term, times P prime over P, but that's precisely the definition of inflation. And so 1 plus r, this 1 plus r times 1 plus I, that is going to be the total return you get in nominal terms for holding a real bond. Non-arbitrage requires that both types of payments are the same. Remember, the nominal bond already pays 1 plus r dollars in the future. The real bond pays 1 plus r times 1 plus I dollars in the future. And those two payments better be the same, or else there will be an arbitrage opportunity. So what we end up having is that 1 plus r times 1 plus I is equal to 1 plus nominal r. That leads to the same equation we had at the beginning. That's called the Fisher equation. For a lot of our applications, it's actually going to be easier to use an approximation of the Fisher equation. For that, you can use this expression. You can see that if you multiply all the terms, you're going to get 1 plus r plus I plus the interaction term. The ones cancel. You get this expression here. But an interesting thing happens. R and I are typically very small, especially for advanced economies like Canada, the US, or most European countries. Both R and I are relatively small. And if they are small, then their interaction is even smaller. So we typically approximate this expression by not taking into account this interaction term, which is small relative to all the other terms. And so we typically say that the real interest rate is the nominal interest rate minus inflation. That's something that people in countries with high inflation, like Colombia used to be in the 90s and early 2000s, this is a relationship people are very much aware of. When they take a loan, they ask what's the interest rate, and you will get answers like 20% or 40%, and you say, oh, that sounds like a high interest rate. But then you take into account that inflation is 20% or inflation is 15%. That was actually the case in my home country, Colombia, in the early 90s. Because you had such a high interest rate, but also a high inflation rate, the real interest rate actually wasn't so high. And so this is an expression that's going to be very useful, and you should always keep in mind when somebody is offering you a loan, or when you're studying, say, for example, credit crisis for economies, this relationship between the interest rate and the inflation rate is very important. Just to finalize this idea, it's that the difference between the nominal interest rate and the inflation, that difference is what's going to give you the real return, because you're getting R dollars, but your dollars are worth less because of inflation, and so you actually only get the difference. Now, when inflation is very low, this doesn't really matter too much, but as I was saying, there are countries that have high nominal interest rates but also have high inflation rates. A good example is also Brazil. Even today, Brazil has high nominal interest rates, but also relatively high inflation rates. Then the final thing we need to discuss is money. So we've discussed two different assets. We've discussed nominal bonds and real bonds, but money is another type of asset. But what makes it special in terms of the discussion we've been having is that there is no payment from holding it. So it's like a zero coupon bond, but there is no discount because the price is by definition 1. It's a zero coupon bond in the sense that if you have $1 today, it pays $1 tomorrow, right? It's the same dollar. But there is no discount because the money is the numeraire. So the price of $1 today is just $1. Now, keeping that in mind, then we get that the real return to holding money, it's 1 plus the zero interest rate it pays, it doesn't pay any interest rate, over 1 plus the inflation rate. There is no payment for holding money, and so actually the return to money, it's minus the inflation rate. So your money, your cash holdings, are losing value when there is inflation and are gaining value over time when there is deflation. That's something important to keep in mind. It's going to come back at the end of the model we're going to develop in Module 6, but it's also going to be important when we're thinking about the model we have now. So the final thing, and with this we finish this rather long video, is that because typically the nominal interest rate is positive, then the real payments on bonds is higher than the payments on money. And so what we're going to discuss next is what are the reasons behind people wanting to have more liquid money when there are more illiquid assets that can be used and pay a higher interest rate. So that's going to be the topic of the next video.